Medieval Europe built cathedrals, minted silver, produced mountains of cloth, and moved valuable cargo across entire seas. None of that happened automatically. Ordinary workers descended underground, climbed wooden scaffolds, stood beside furnaces, handled rotting animal hides, and worked inches from machinery powerful enough to break bone. They were not soldiers. They were not executioners. Most were simply trying to earn enough money to survive. But in medieval Europe, some occupations had an additional requirement. You had to survive the occupation itself. Here are 7 medieval jobs that could kill you before payday. Number 7. The miner. Medieval Europe consumed metal constantly. Iron became plowshares, nails, hinges, horseshoes, knives, armor, weapons, and tools. Lead covered roofs and entered construction. Copper became vessels and alloys. Silver became wealth itself. But metal had to come from somewhere. That somewhere was usually underground. By the High Middle Ages, important mining districts operated across England, Bohemia, Saxony, the Alps, and other parts of Central Europe. Some mining communities became large enough to develop specialized laws, commercial networks, and entire supporting industries. The valuable material was buried inside rock, so workers followed it. A miner entered narrow workings with iron tools, wooden supports, primitive lamps, ropes, baskets, and whatever ventilation the mine could provide. The deeper the shaft became, the more ways it could kill him. Water accumulated underground constantly. Without modern electric pumps, drainage required channels, buckets, mechanical devices, or human labor. A sudden inflow could turn the lowest workings into a trap. Then there was air. Open flames consumed oxygen and produced smoke. Dust remained suspended in confined spaces. Smelting and ore processing exposed mining communities to additional fumes and metal contamination. But the fastest killer was often above the miner's head. Medieval mines relied heavily on timber supports where the natural rock could not hold itself. Wood could rot. Supports could shift. Excavation could weaken surrounding material. A cracking ceiling gave little warning, and a miner working deep underground had nowhere to run. Even when the mine itself remained stable, workers hauled heavy ore through cramped passages, climbed shafts, handled tools in darkness, and worked around open pits. One mistake could become permanent. The ore might eventually reach the surface, the miner might not. And strangely, the next occupation involved a material that looked much safer than a collapsing mountain. It was just white stone, until workers heated it. Number 6. The lime burner. Medieval Europe built with stone. Castles required mortar. Town walls required mortar. Churches required mortar. Monasteries, bridges, towers, and houses all consumed enormous quantities of binding material. One of its essential ingredients was lime. The process began with limestone or chalk. Workers broke the stone, transported it, and loaded it into kilns with fuel. The kiln was then fired at extremely high temperatures for a prolonged period. The goal was to transform ordinary calcium carbonate into quicklime. The chemistry worked. Whether the worker remained comfortable was irrelevant. A lime kiln was essentially a controlled industrial fire. Someone had to load it. Someone had to maintain it. Someone had to approach it after firing. Heat was unavoidable, so was smoke. But the finished substance created another problem. Quicklime reacts strongly when mixed with water. This process, called slaking, releases heat as the material changes chemically. The resulting lime could then be used for mortar, plaster, whitewash, and other purposes. For workers handling it directly, however, quicklime was not simply powdered stone. It was caustic. Dust could enter the eyes. Wet material could attack skin. Fresh lime contacting moisture could generate enough heat to worsen burns. Workers handled these materials without sealed goggles, chemical gloves, respirators, or specialized protective suits. Medieval lime production also required repetitive heavy labor. Stone went in, fuel went in, burned lime came out. Each batch required workers to move material toward or away from intense heat. Even storing the product required care because water was useful only when workers wanted the reaction to occur. Rain was less cooperative. The material that helped hold a castle together could injure the people making it. There was at least one small advantage. A lime burner usually worked close to the ground. The next workers did not. They carried stone and timber upward until a single loose board could place them higher than many town walls. Number 5. The medieval construction worker, medieval builders produced structures that still survive centuries later. That achievement can make the technology behind them appear almost magical. It was not. It was organized labor. Cathedrals required masons, carpenters, quarry workers, roofers, mortar makers, laborers, haulers, and specialists working for years or even generations. Castles required the same. Every block had to be cut. Every beam had to be shaped. Every load had to be transported. Then much of it had to be lifted. Medieval builders used scaffolding, ropes, pulleys, lifting frames, cranes, and tread wheels to raise heavy materials far above ground level. The machines could be ingenious. The worker remained human. A mason standing high on wooden scaffolding had no modern safety harness. A carpenter crossing structural beams had no steel guardrail. A worker beneath a hoisted stone had no hard hat capable of changing the outcome if hundreds of pounds suddenly dropped. Falls were only one possibility. Stone could crush feet and legs, timber could roll, ropes could snap. Loads could swing unexpectedly. Chisels, axes, and saws were designed to cut resistant material. Human flesh offered less resistance. Construction also placed multiple teams in the same vertical space. One group could work above another, while tools, stone chips, timber, and lifting equipment moved constantly. Gravity did not need much assistance. A dropped object accelerated on its own. The greater the cathedral became, the greater the potential fall. Medieval builders understood these dangers, but construction could not simply stop. Wealthy patrons wanted churches, defensive walls, halls, bridges, and fortifications. Stone had to rise. Workers rose with it. Some cathedrals took generations to complete. The buildings outlived almost everyone who constructed them. For certain workers, considerably sooner than expected. But falling masonry was at least visible. The next job placed workers beside a machine that could appear perfectly calm while standing still. Once water reached the wheel, that changed. Number 4. The miller. Few medieval occupations were more essential than milling. Grain was a basic food source across Europe, and turning grain into flour required enormous amounts of repetitive grinding. Doing it by hand was slow. Water solved the problem. By the medieval period, water mills were widespread across many European regions. Flowing water turned a wheel. The wheel transferred energy through shafts and gears. That energy rotated millstones or powered other mechanical processes. It was efficient. It was continuous, and it had no idea whether it was crushing grain or a person. The miller worked directly beside the mechanism. Grain had to be fed correctly. Millstones required adjustment. Gears required attention. Water flow had to be regulated. Barracages had to be cleared. Weir had to be inspected. Most of these tasks happened in an environment filled with moving wood and stone. A loose sleeve could become a problem. So could long hair. So could reaching toward machinery before it had completely stopped. Large rotating components stored enough mechanical energy to drag, trap, strike, or crush anything caught between them. The millstone itself created hazards. Grinding stones were heavy, and maintaining or repositioning them required physical effort. A damaged stone rotating at speed could become dangerous in ways that were difficult to predict. Then there was the water. A water mill deliberately redirected rivers or streams through channels, mill races, sluices, ponds, and wheels. Workers maintained those systems. That meant walking beside fast-moving water, sometimes on wet surfaces, and sometimes during bad weather. Falling into the wrong channel could place a person close to the wheel that the water was powering. The mill existed to turn a natural force into mechanical force. The miller worked in the middle. Bread depended on him. So did the machine. But the next occupation had no riverbank to climb onto if something went wrong. Its workers could be hundreds of miles from shore. And sometimes nobody ever learned what happened to them. Number 3. The medieval sailor, medieval trade crossed enormous distances. Wine moved between regions. Wool crossed seas. Grain fed cities. Salt preserved food. Spices traveled thousands of miles. Luxury goods moved between Asia, Africa, the Middle East, and Europe through overlapping land and maritime networks. Ships carried a large part of that commerce. Sailors carried the ships. Their workplace was a wooden vessel exposed to weather powerful enough to erase it. There was no satellite forecast warning a crew that a storm system was developing beyond the horizon. There was no engine allowing a sailing vessel to ignore unfavorable wind. There was no radio distress call. there was no helicopter rescue. Once conditions deteriorated, the crew worked with what the ship carried. Storms could tear sails. Rigging could fail. Masts could break. Cargo could shift violently. Water could enter through damaged hull planking. A vessel taking on water required the crew to remove it manually while also keeping the ship under control. The sea created other problems during ordinary conditions. Decks became wet and slippery. Sailors climbed rigging above the deck. Heavy ropes moved suddenly under load. Anchors, cargo, timber, and equipment could injure workers long before weather became dangerous. Falling overboard could become fatal almost immediately. A sailing ship underway could not simply stop. A man in heavy clothing entering cold water might disappear behind the stern before the rest of the crew fully understood what had happened. At night, the odds became worse. Navigation itself carried risk. Medieval sailors relied on accumulated knowledge, coastal landmarks, stars, winds, currents, sounding methods, and later increasingly sophisticated navigational instruments. But knowledge could not remove rocks from the sea. Shipwrecks repeatedly destroyed vessels and cargo throughout medieval maritime history. Some losses entered written records because merchants wanted compensation or because the cargo was valuable. The dead sailors often required less paperwork, and there was one detail that made sailing different from almost every other occupation on this list. A mine collapse left a mine. A construction fall left a building. A ship could disappear entirely. Still, sailors at least spent much of their working day surrounded by open air. The next workers spent theirs surrounded by dead skin, soaking vats, sharp blades, chemical reactions, and a smell strong enough to affect where cities allowed them to work. Number 2. The tanner medieval Europe consumed enormous amounts of leather. Shoes were leather, belts were leather. Horse harnesses required leather. Weapon scabbards required leather, bags, gloves, straps, bookbindings, armor components, containers, and countless everyday objects depended on it. But an animal hide does not naturally become durable leather. It decomposes. The tanner's job was to stop that process and transform the hide into something useful. That required several unpleasant stages. Fresh hides arrived carrying flesh, fat, hair, dirt, blood, and organic material. Workers soaked them. They scraped them. They removed tissue. They loosened hair. They treated hides with alkaline substances and later tanning agents, commonly derived from materials such as oak bark. Large amounts of water were involved, so were vats. The work was wet, repetitive, and physically demanding. Sharp scraping tools moved repeatedly across slippery hides. A mistake could move the blade somewhere else. Tanning substances could irritate exposed skin. Alkaline processing materials created their own risks. Workers spent hours with hands and arms exposed to liquids designed specifically to alter biological tissue. That description included the hide. It could also include the worker. Tanneries frequently developed reputations for offensive smells because decomposition and waste were built into the process. Animal tissue, dirty water, used tanning materials, and waste had to go somewhere. In dense medieval towns, industries involving strong odors or polluted water often became socially and geographically distinctive. A tanner could finish the day carrying the smell of his occupation home with him. If he finished the day, wet floors encouraged slips. Heavy hides strained backs and shoulders, sharp tools cut, chemical and biological exposure accumulated. The final product looked clean, strong, and expensive. The process did not. But tanning was not the strangest medieval job involving foul liquid. Another group of workers treated one of Europe's most valuable products by soaking and pounding it. And one traditional cleaning ingredient came directly from the human body. Number 1. The fuller medieval Europe's textile industry generated extraordinary wealth. Wool in particular became economically important across regions such as England, Flanders, northern France, and Italy. But freshly woven wool cloth was not automatically ready for market. It required finishing. One of the most important stages was fulling. Fulling cleaned the cloth and compressed the fibers, making woolen fabric thicker, denser, and more durable. The process sounds harmless until its ingredients are examined. Cloth was soaked and worked repeatedly. Traditional fulling processes could use substances including fuller's earth and stale human urine. Urine contained ammonia compounds useful for cleaning grease from wool, so fullers collected it. Then they worked with it, In earlier manual systems, workers could tread cloth underfoot in vats while the material soaked. Imagine spending hours standing in a mixture deliberately selected because it could strip oils from wool. Then industrial technology improved the process. For the cloth, water-powered fulling mills increasingly used mechanical hammers or stocks to beat wet fabric repeatedly. This reduced the amount of manual pounding required. It also introduced another machine capable of striking with far more force than a human arm. Heavy wooden components rose and fell automatically. Again and again and again, the machine did not become distracted. It did not become tired. It did not decide that a worker's hand was different from wet wool. Mechanical fulling joined the familiar medieval combination of water, slippery floors, heavy materials, repetitive labor, and exposed moving machinery. Wet broadcloth itself could be large and difficult to handle. Workers moved it between stages, inspected it, stretched it, treated it, and prepared it for further finishing. The finished fabric might later become expensive clothing worn by merchants, nobles, clergy, or prosperous townspeople. Few of them had to think about the person who had stood in the cleaning vat. That was the final irony of medieval labor. The cleaner the product became, the easier it was to forget how dirty the job had been. These 7 occupations reveal a side of medieval life that battles and royal murders often hide. Danger was ordinary. It did not always wear armor. It did not always carry a sword. Sometimes it was a wooden support holding several tons of rock. Sometimes it was powdered lime reacting with water. Sometimes it was a scaffold board 60 feet above the ground. Sometimes it was a turning gear. Sometimes it was an Atlantic storm. Sometimes it was a vat filled with animal hides. Sometimes it was a wooden hammer pounding wool. Medieval economies depended on people working directly beside forces they could control only imperfectly: heat, gravity, water, mechanical power, chemical reactions, rotting organic material, and stone. The products could be extremely valuable. Silver entered royal treasuries. Mortar held castles together. Masons raised cathedrals. Millers produced flour. Sailors delivered international cargo. Tanners supplied leather. Fullers transformed wool into valuable cloth. Civilization received the finished product. Workers absorbed the risk. And unlike the stone walls, silver coins, leather bindings, and wool garments they produced, many of their names did not survive. The work did. The workers were replaceable.